start some introduction and we'll start the meeting. So on behalf of Tamil Nadu Science Forum, Popular Science Lecture Group, I extend my warm welcome to you all. Today we are going to have a webinar on academic intelligence. This lecture shall be delivered by Dr. K.P. Mohanan. The meeting shall be in English. We would like to have a brief introduction about Tamil Nadu Science Forum and the speaker, which shall be done by Dr. Krishnasamy, an important guide for the PSL, and Dr. Ramanujam, another important guide for the PSL, to introduce the speaker. The KPM shall talk about 40 to 45 minutes, and we'll have a question answer section for another 45 minutes. We'll try to wind up everything by 6 o'clock, not more than that. So PSL is part of the Tamil Nadu Science Forum, and it started functioning in 2018 only, although TNSF is founded in 1980. The PSL came into existence when we decided to strengthen the activities of the TNSF in the higher science area. We conducted the 59 lectures so far, and this is the 60th lecture. So when we go for the first lectures, no, we go to the college and we say that so there are something which need to learn beyond your academic activities. That's the reason we started the PSL. And that's the campaign we have now. This lecture is going to strengthen our case. So what we have learned in the academic is not enough, and we have to go beyond that. So that is a whole objective behind this lecture. See, we used to have the lecture in the lecture hall initially, and after the pandemic period and the peak pandemic period, we did it in the online meetings, and so after peak pandemic period, it has gone to hybrid mode. This meeting is going to be in online mode only. We don't have any hybrid mode. So we request all of the audience to mute your mic so that when the lectures goes on, if you have any question, you can raise your hand. Naturally, if the speaker allows you to ask questions, you can speak and you can unmute and speak. We would like to get the feedback on this webinar from you, and we have posted a Google form. Please click the Google form and fill your opinion about about this lecture. We also provide the link link for becoming a member of TNSF, and we also have a couple of social media group. We have Yammer, we have WhatsApp group, we have Google group, as well as Telegram group. All those groups are provided with the links in the chat box. You can click and do that. With that, let me ask Dr. SK to introduce Tamil Nadu Science Forum. After that, Jam will introduce the speaker. Thank you.
Yeah. Thanks, Vijayan. So welcome everyone. And my pleasure to talk about the Tamil Nadu Science Forum, in which I've been for quite a long time. Tamil Nadu Science Forum initially started around 1980s when by a small bunch of researchers, basically from Madras University, students and so on. They, as a set of small lectures, popular science lectures in the city. And then it remained fairly static in Chennai until the Arivadi Iyakkam sort of took it all over the Tamil Nadu into various districts. And so after that, it has been growing more in terms of not only establishing its presence in the districts, but also in terms of different activities. So the basic grounding has been on children's schools activities, especially through the National Children's Science Congress participation and taking it forward. And then also a Youth Science Festival started. And Tamil Nadu Science Forum has got a lot of important landmarks and contribution to especially school education. One such more recent is the one which through its efforts, participation in the government Illam Thediya Kalvi program. I think all these school education projects, JAM has been a major push behind it. And Ramanujam has been a major push behind it. And then we now also got into women's equality, Samam, and a lot of women's groups have started in various districts. And then we have on development, interventions in development, and so basically on livelihood issues, So there's been both horizontal and vertical expansion of Tamil Nadu Science Forum. And one of the major points of growth has been the recent development, thanks to Vijayan, of this popular science lectures, which basically been targeted at college students, and it's been doing very well. So I think that's just Tamil Nadu Science Forum, of course, has a structured body, and it's not an NGO; it's a science movement which does not receive any outside funding. There's no foreign funding or other funding, and basically it runs through various projects from the government and other such sources. Yeah, so with that, is that okay, Vijayan, for Tamil Nadu Science Forum? I think I'll pass it on to Ramanujam for the speaker.
That's fine. That's fine.
Yeah.
Short introduction is enough. Speakers are eagerly awaiting for the main lecture.
Yeah. Thank you.
Thank you. It's my pleasure to introduce my dear friend Mohanan to this audience in Tamil Nadu Science Forum. So welcome Mo to TNSF. So KP Mohanan, or Mo as he is very well known, is a distinguished linguist. He got his PhD from linguistics from MIT, Cambridge, United States, and then he taught in many places, including University of Texas at Austin, Stanford University, and I think for some years at the National University of Singapore. Mohanan and his partner Tara Mohanan are both eminent linguists, and both committed to developing an inquiry-based pedagogy. At the National University of Singapore, they both co-designed a course on inquiry-oriented undergraduate program in linguistics, which I think has become a cornerstone for, I would say, a cornerstone for inquiry-based learning. And in the last decade, Mohanan has been instrumental, the Mohanans, I should say, have been instrumental in setting up this wonderful group called Think, or ThinkU, as I usually call it, as a group committed to developing a way of doing inquiry-based learning, transdisciplinary learning, and not just talking about it, but actually developing materials, developing pedagogy, working with students of all ages across the country. And a little while ago, SK called Science Forum a science movement, and I think the Think is becoming a movement for inquiry-based learning, I would say. And so he has deep understanding of the nature of academic knowledge and epistemology, how human beliefs come about, and how we know what we know. And so it's wonderful to have Mohanan talk to us about academic intelligence. And well, we all know, I think we all have a very good understanding of academic stupidity. So it's good to hear somebody articulate something on academic intelligence. Okay, over to Mo.
Thank you. Thank you, Jam, for a very complimentary, flattering introduction. Okay, so let me see if I can get this right. Okay, can everybody see the screen?
Yes.
This is going to be the general structure of the talk. In part one, I'll address questions like what is intelligence, what is academic intelligence, and how to acquire academic intelligence. And part two is the most important part. I'll go through a large number of examples. I may not be able to go through all the examples in the PowerPoint, but you have the PowerPoint slides in a PDF format. If you haven't already downloaded it, it must be there in your chat. And so do look at the PDF. And then in the last part, very briefly, I can guide you to some places where you can find the similar exercises. Okay, that's going to be the main structure. So let me begin with part one. Very simple. What is intelligence? we're going to define intelligence as the capacity to do things with our mind. So this is similar to the capacity to do things with our body. We have similar capacity to do things with our mind. We'll come back to this a little later. And academic intelligence is the capacity to do things with our mind, like academics. So how to think like a philosopher, how to think like a mathematician, a theoretical physicist, an experimental biologist, a psychologist, theoretical linguist, sociologist, historian, and so on and so on. Our aim in this enterprise is to what is common to all of these different academics, the core of academic thinking or academic intelligence, with some variations. There is a difference between thinking like a mathematician and thinking like an experimental biologist, in spite of the core. So we pay attention to both the similarities, the core, and the variations. Okay, so can we acquire this? And our answer is yes, of course. Academic intelligence can be acquired. It can be strengthened. And this is exactly like the capacity to do things with our body. If you exercise your body, if you have the right kind of nutrition, our body grows stronger. Exactly the same way our mind grows stronger with appropriate mental nutrition and mental activity. And this is something that people tend to ignore. Intelligence is not something that you're born with. There might be a birth factor, but most important part is what you do with your mind later after your birth, that matters. Okay, that's the first part. Now let's go through the examples. This is where the meat of this seminar is. Okay, so let me begin with this idea that there are things that we take for granted quite often, especially if we get something from an authority, from a textbook or a teacher, we take it for granted. So here is an example. I'm pretty sure that all of you have seen the candle experiment. What you do is you have a candle, you light it and put it in some kind of a tray of water, and you cover it with some glass jar. And you find that the candle, the flame goes off very soon. And the water level rises. And if you measure it, you will see that it is about 1/5 of the total quantity of the height of the air in the jar. And so this is taken to be evidence for saying that air is 1/5 of air is oxygen. And everybody believes, yes, of course, that is evidence for it. Is it? So instead of having one candle, if you have 3 candles lit and do the covering, and you'll find that the water level goes up further. So is it the case that the 3 candles exhausted more oxygen, but oxygen is supposed to be 1/5 of the air? That's one problem with this experiment. The second problem is this. Yes, it absorbs oxygen from the air, but it also combines that oxygen with the carbon from the candle and leaves out carbon dioxide. So it is not that it simply absorbs oxygen, it puts in more stuff. So shouldn't the water level go down instead of going up? If you ask that question, you realize that you haven't understood why the water level goes up. It is not that it has absorbed the oxygen, it is something else. The presence of oxygen in the water, in the air, has nothing to do with the water level going up. Once you realize that, you wonder, why did the water level go up then? 2 or 3 things happen. One, you discover that the textbook statement about evidence for oxygen in the air is actually very faulty. Number 2, there is a puzzle here. Why does the water level go up? Those questions are the beginning of academic intelligence. You begin to doubt your textbook. You begin to start thinking on your own. You're puzzled by something, you look for explanation. So that's one example of beginning of academic intelligence. Doubting authorities, textbooks, and teachers and other experts, and thinking on your own, learning on your own. Take another question. we take for granted that there is something called social science. So in schools and in universities, the division is like mathematics, physical sciences, and social sciences. And the idea is that social sciences are not sciences. That's the implicit assumption. Two questions. Why isn't psychology a science? Why psychology, which studies the mind, why is it social science? And if psychology is not a science, can psychiatry be a science? Psychology is about normal human behavior, also some abnormal human behavior, but psychiatry is healing abnormal behavior. And what is social about psychology? Another question that you ask is, what about biologists who study society, chimpanzee society, bacterial society, and so on, bird societies? Are these biologists social scientists? What is social about social science? And why isn't social science a science? Now, what we're doing in asking these questions is to start doubting these institutionalized divisions of science versus social science. That is another example of questioning what we otherwise have taken for granted. And in this set, my third question is, do plants breathe? We might think immediately, oh, plants do not breathe because they don't have lungs. Possible. So you are defining breathing as an activity performed by the lungs. All right. What about fish? Do fish breathe? Do fish have lungs? Can we define breathing as taking in oxygen from the air, from the outside, from the environment? Not necessarily air, but also water. If you say that taking air from water is breathing, then fish breathe, whether or not they have lungs. Well, by the same token, plants also breathe because plants take oxygen from the air. Many plants do it. So in order to answer the question, do plants breathe, we have to define breathing. And the reliability of your answer depends upon the definition that you give and the reasons that you give for the answer. And that's where, with activities like that, academic intelligence is developed. Let me take a similar example, not exactly the same. Suppose I tell you, intelligence is the capacity to do things with our mind. This is the definition that I gave earlier. And I say, plants have intelligence. Therefore, if those two propositions are accepted, we have to conclude that plants have minds. Now, that could be a little strange for people who think that we don't have minds unless we have a neural system. Plants don't have a neural system. But if we accept the first two propositions, intelligence is the capacity to do things with their minds. Plants have intelligence. Therefore, plants do have minds. Here is another argument, a slightly different conclusion. Intelligence is the capacity to do things with their minds. Plants do not have minds. Therefore, plants do not have intelligence. Notice that our conclusions are completely contradictory. Depending upon which proposition we take as our premise, our conclusions are completely contradictory. And you can't have both. So avoiding logical contradictions, an important part of academic intelligence, is a way of saying, do not have logical contradictions, change something or the other. It doesn't tell you which one. Make some modification somewhere such that you avoid logical contradictions. So there are two ways of doing it. One is to accept that plants have intelligence, in which case you have to accept that plants have minds. The other is to reject that plants don't have minds, in which case plants do not have intelligence. The principle of avoiding logical contradiction doesn't tell you which way to go. It is up to you to decide. And this kind of thinking is very common in academia, but very uncommon in ordinary life. You need a certain kind of trained mind to do that. Okay, let's go through a few more examples. This may look very, very silly. What's a line? Everybody knows what a line is. Let me ask you a simple question. Can you see a line? Take a few seconds to answer that question in your mind. And most of you might say, yeah, of course we can see lines. See, I can draw a line on a blackboard or a piece of white paper, and I can see it, right? Pause for a moment. The description of a line given in Euclid is that lines are things which do not have breadth. So a line has length, but not breadth. 0. Is it possible for you to draw a line with no breadth whatsoever on a piece of paper or on a blackboard, whiteboard? No, you can't. So imagine, for example, you have a rectangle, reduce the breadth, keep reducing the breadth until there is 0 breadth. Can you see that object when a rectangle becomes a line? No, lines are invisible. Invisible lines? What exactly is a line? Then it is not a line. Is not something that you draw on a piece of paper. It becomes not very easy to answer the question what a line is. One possible way of answering that question would be a line is an intersection between two surfaces. What's a surface? Okay. If you start asking those questions, you realize that something that you took for granted, line, something that we learn in primary school, you don't really know what it is. And that awareness that we don't know what we think we do is the beginning of wisdom. Okay, so let's see this one. What's a straight line? Again, the same difficulty arises. Okay, so one answer to the question is a straight line. If you have points A and B, a straight line is the shortest path from between A and B. Shortest. But how do you know what is shortest? You cannot measure it, right? Lines are invisible. So how do you know, given two lines from A to B, how do you know which one is shorter? And you scratch your head and say, gee, I have no idea. And saying, I have no idea is a good thing. Ignorance is the beginning of knowledge. If you do not realize that we are ignorant, then we cannot learn. Right? Take the third question. Can two straight lines intersect at two distinct points? The immediate answer would be, of course not. You can't. You can only have two lines intersecting once. Try this one. You take a spherical object and draw a straight line. Can you draw a straight line on a spherical object? Yes, you can. If you can figure out the shortest path, then of course you can take the shortest path on a spherical surface. Like, for example, if you take a string and stretch it, of course, string is not a line, but you get a sense of what it is like to have the shortest possible path. Then you have a straight line on a spherical surface. So I draw a line like that, which is a circle-looking straight line. It is a circle too, a line that meets itself, a straight line that meets itself, and then draw another one. And then you see that the two lines intersect in two different places. You can see that in your mind. So it really depends upon whether a straight line can meet itself when extended, or a straight line can meet itself when extended. Two different geometries. So before answering the question, can two straight lines intersect at two distinct points? You have to ask the question, in which geometry? In which world? In the Euclidean world, you can't. But in the spherical world, the world that Einstein was using, yes, two straight lines can intersect at two distinct points. Notice that by challenging the established assumptions, what we take for granted, we have gone from Euclidean geometry to spherical geometry. You have expanded the scope of your understanding, the scope of your inquiry, the scope of your thinking. So this is the kind of mind gym activity that can increase your academic intelligence. And let's take a similar example. I apologize for doing all this stuff in what looks like mathematics, but I'm just taking mathematical thinking, not technical mathematics. This mathematical thinking is open to everybody. And it's easy because all these concepts are available to secondary school students, even primary school students. The subject matter is fairly straightforward. What's a right angle? Okay, the immediate answer is right angle is 90 degrees. So that means in order to tell whether an angle is right angle or not, you have to take a protractor and measure the number of degrees. How can you measure if you cannot see lines? According to Euclid, lines are invisible entities because they have zero breadth. How can you measure the angle between two lines? Problematic. So what is a right angle? I'm not going to pursue that. I'll just leave you with that discomfort that you don't really understand what a right angle is. There are ways of doing it, but I won't discuss them here because it's unless you have a strong sense of discomfort that you do not know, that your mind will not start working on those questions. So I'll go to the next one. What's a straight angle? Well, straight angle, you can say is 180 degrees, but if you don't want to use the word degrees, you say two right angles. Okay. And what is that? If you take a straight line, AB, and put a dot in, a point in between A and B, ACB. Angle ACB is a straight angle. All right. So far, so good. How many points can you have in a straight line segment? Infinitely many points. So given a straight line segment AB, you can put your C anywhere. There are infinitely many straight angles. Infinitely many straight angles for one straight line segment. So how about a triangle? 3 straight line segments. What is the sum of angles in a triangle? If it is infinitely many straight angles for one straight line segment, how many for 3 straight line segments? The answer is infinitely many. But you have been taught that the sum of angles in a triangle is 180 degrees, 2 right angles. There's a logical contradiction. So what should you believe? What should we accept? Okay, again, I'm going to leave you with that sense of discomfort, not investigated question. The last question should really make you extremely uncomfortable. Okay. Now, you have been taught in your school, secondary school, the following things. Light is a ray. But our experience, if you ask, a student who has not been exposed to optics in school, we all think of light as a substance. So if you turn on the light or if you light a candle, there is a substance called light that fills the room, and we are able to see things because of that substance. In fact, there were theories of vision using this idea that light is a substance. That's our intuition, a kind of experiential understanding. Why should we change that to light as a ray? Okay, but then we are also told that light is a particle. What means light is not a ray? And then we are told that light is a wave. Which one is it? Okay, is light substance, ray, particle, wave? All of these are taught to us, and we believe, accept all of them. But there are logical contradictions. If light is a ray, it is not substance, and if it's a particle, it is not a ray. And more interestingly, a ray is a geometric object. A ray is a geometric object that is the starting point, and the arrow means it doesn't end. The other side is infinite. But it's an object. Ray doesn't travel, does it? So why do you say light travels? And what's the evidence for saying that light travels anyway? Okay, you ask those questions, and then you slowly begin to realize that you don't fully understand. And the important part is not simply the recognition, the awareness that we do not understand, but what happens after that? You start thinking on your own. That thinking on your own adopts various kinds of thinking that academics use in their research, mathematicians, physicists, biologists, psychologists, and so on. So let me, I don't want to use, I can give you more examples if you want, but for now, I think this is sufficient to give you a taste of what academic thinking is. And you must be already fairly uncomfortable. Where do we find this? Where do we find these similar exercises, tasks, activities? Where do we find the mind gym? Well, we Think has a course which is free, completely free. Think Education has lots of resources, again, completely free. All that you have to do is to go to our website. There are so many of them. We have many textbooks, we have many activities, many articles, we have textbooks, we have videos, webinars. There is sufficient material at our website to keep you busy and get almost like a master's degree in academic intelligence. You can do this on your own. You don't need anybody's help. All that you need is go to the resources. You could also go through our course, Enquiry and Integration in Education. Then you can find the announcement of that course at our website. I think the deadline is April 24th, something, and the course begins early May. And once you join that course, you can continue with us, if you're interested. Developing your mental abilities, developing your academic intelligence is not something that ends with a workshop or with a course. It's something once you start, it goes on forever until your death. It's a continuous climbing of a mountain that doesn't have a top. So you don't stop. You don't get a degree such that you can stop. Your learning is forever. Okay. So I think I should stop. I don't know how much time I took. I was hoping to finish in about 45 minutes. I finished much earlier. We can now discuss your questions and comments. I may not be able to see all the hands going up or in the chat. So if somebody can help me to see who has raised their hands or type something in the chat box, I would answer your questions. Thank you.
Somebody has put on chat that light travels in Dutch. So, okay.
This person called Tejasvi Kalina, is that? Sorry,
I don't know. Surekha, I think.
Okay, so how do we take questions? I can't read anything in the chat box.
Vijayan, I think.
Yeah. Chat box is accessible. No, you can see that.
You should.
You have the bottom icons in the bottom. You see the chat. You just click it, the chat box will pop up.
Okay, I should exit from.
Let me read that now.
Yeah.
Sureka,
that's easier. Yeah.
Yeah, go ahead, Vijayan. So you were starting.
The question from Sureka is light travels. It do.
Yeah, it's not an answer. It's not a question. It's an answer. I mean.
Yeah. How do you know that? Somebody told you that? The question is, why should you believe what you have been told?
Can you hear me?
Yeah.
Yes.
Yes, I'm Dr. Sureka from Central Polytechnic College, Taramani, Chennai. From the Department of Mechanical Engineering. Yeah, so I've completed my BE Aeronautical Engineering. So, I feel like I know a bit about sounds in the lights. It travels, sir. Say, for example, if you switch on the headlights of a car, and when you watch it moving, when it is at the point A, probably the visibility of the things in front of the car is a bit shorter. But when the car progresses, moves, you can see furthermore, right, sir? So it is because it travels. When it travels, I could see bit longer distance.
Yeah, so
Isn't
you're
it-
saying that you can explain the phenomenon that if you have a light source, as you go farther and farther, it becomes less bright, right?
Yes. Yeah.
Now, that can be explained by saying that light is a kind of substance, and that substance is such that as you're farther and farther away, it gets dimmer, it gets less. So there is no reason, that does not provide evidence to believe that light travels at all. I agree that this is what textbooks have told you, and I'm suggesting you should ask the question, why should I believe the textbook? The answer that you have given does not provide evidence for light traveling. I'm not saying that it is false, remember? I'm simply saying, what is the evidence that you can cite? Let me give you another
experience.
Yeah.
Maybe like I may not be knowing like how I'm receiving the solar radiation from the sun. It is light year apart from away from us, but still like I can feel the solar radiation on the Earth's surface. But when a car moves in front of me during night time, I can visualize that, sir. I'm saying this out of my experience, not from the textbook, sir.
Your experience tells you that the car moves and the light source moves.
Yeah, light source. Car is a light source.
Yeah, the light source moves, but not the light.
Yeah. No. Light source moves, and because of that, the area of the coverage of the light, it moves, which means that the light travels. The distance covered by the light moves because of which is created by the light source.
Okay. Suppose I hold my hands like this and I move. You can see that as I am moving, this area between, or this stuff between my hands also moves. But
no, sir, not the same. Maybe you can say like you're throwing a ball. Your hand is the source which throws the ball, and you imagine the ball as the light.
Yeah, think of it this way.
Like throw the ball. Yeah.
Okay, as somebody who has an engineering degree, you know the speed of light. I mean, I'm not denying that light travels. You know the speed of light, right?
Yes, sir. Yes, sir.
Is it possible, given at that speed, can you see light traveling at that speed?
It is not achievable. Maybe we can travel.
You cannot see it. You cannot experience light traveling. It's impossible. If it is true that light travels at the speed at which it is, stated to be true in textbooks, you cannot see it. You cannot experience it. So there must be some other piece of evidence. So I suggest that you think of that evidence that tells you that light does travel. And this is kind of like this. Let me give you another example. You have been told that the Earth revolves around the sun and spins around the on an axis.
Yeah.
Why should you believe that? Do you have that experience of the Earth spinning or the Earth?
Because I just the day and the light is because of the revolution and the rotation of the Earth.
Not necessarily. That could be because the sun is moving around the Earth. You get exactly the same thing. Why should you reject Ptolemy's theory and accept the?
Sir, like it is something like I usually ask my students why it was 1 + 1 is equal to 2. Why it is not 3?
Precisely.
It is something like that, sir.
Yeah, that's a good question. In fact,
it is the literature survey. It is from the survey. That is how I can justify this.
There is
1
no
+ 1 is 2. I don't know it is 2, but my mentors, my superiors, and all others, they said it is 2. Hence, I'm also following it as 2.
Yes. So in advertisements, a toothpaste advertisement would say this toothpaste cleans 85 times better than some other toothpaste or something. And you believe that? Do you believe TV ads? Why should you believe textbooks? Okay. No, I am not suggesting that the Ptolemaic theory is true, or that the other theory is false or anything like that. I'm simply saying, if you believe something, you must look at the evidence. Now, I can look at this question and give you the evidence for the belief that the Earth revolves around the sun, but it'll take at least 3-4 hours. It's not simple.
Okay, sir. But anyways, what I understood is deeper research is required in each and every
you don't need
understanding.
deeper research. 8th grade students can understand it. It takes some time to think very carefully, that's all. But the first part is distrust. Start doubting your textbook. Start doubting your teachers, which means start doubting yourself. That is where knowledge begins.
Yes, sir. Agreed. Okay, so thank you, sir. Thank you.
Other questions?
Excuse me, sir.
Yeah.
Sir, this is Tejasvi from Basilwood School,
Uh-huh.
Hyderabad. Sir, I just have a doubt. We nowadays, we can see artificial intelligence working, and it has a very high boom. So, is academic intelligence better or artificial intelligence? Because we just give some inputs and artificial intelligence and it gives certain answers, but how far they are true, we don't know, no, sir. So
I'm not quite sure how to answer that question because Ramanujam and I have been talking about this for quite some time. There are two ways of answering the question. I can tell you what I think, what my opinion is. But that is not a good thing because why should you trust my opinion?
yes,
I
sir.
just told you.
Yes, even I have that doubt, sir. So how far? Let me see how far you can satisfy me.
Okay, so giving you my opinion is not, and you are accepting my opinion is not a good thing. You have to say, why should I believe what you're saying? Well, you will have to find out on your own by experimenting with ChatGPT. And you can ask the kinds of questions that I have been asking you in this. If you give examples of this kind, you will find that ChatGPT is getting very confused. What ChatGPT does is to look at all the internet material, all the written language materials of the internet, and bring together all of that material to summarize the stuff. So if it is there in the internet, ChatGPT will find it and give you an answer. But if it is not there in the internet, it will not. So if you ask a question like, I'm just guessing, maybe ChatGPT can answer it and Jam can tell me whether it can or not. Suppose I ask the question, here's the case. Take a triangle ABC, A, B, C on top, bring point C down all the way, and such that it is on the straight line, ACB. So this ACB has three, even though it is on the same straight line, it has three segments, straight line segments, AB, BC, and CA. Okay, the question is that a triangle? Now, tell ChatGPT to define triangle in such a way that the answer is yes, but also define triangle in such a way that the answer is no, both. This is what a mathematician should be able to do. This is what mathematical intelligence will allow you to do. Find out if ChatGPT can answer that question. We have been doing these experiments. There are many such things that even little children can do, which ChatGPT cannot do. There are things that ChatGPT can do, which is extremely difficult for humans. But there are also things that primary school kids can do, which ChatGPT cannot. I have only given you a kind of suggestive pointer to answer your own question. As I said, don't believe what I'm saying. Do your own experiments.
Sir, I have one more doubt further. Like, if we start an experimentation, it takes a lot of time. And nowadays, people are behind the time, which is very much less to them. So,
you mean experiment with ChatGPT or other kinds of experiments?
Sir, if we compare the experimentation with ChatGPT and the experiments in the science lab, experimentation in the science lab takes much time.
Yes.
Because each and everything should be taken into consideration. But ChatGPT gives answers or the observations within no time. So nowadays, people are behind artificial intelligence. So how far it is believable?
There are two things that you can do. One is to accept what other people tell you blindly. And the other is to decide, I'm not going to believe everything that other people are going to tell me. I'm going to question them because people tell you contradictory things. Let me give you one example. How many elements are there? So is air an element? Is water an element? What's your answer?
No, sir.
They are not, right? That's what modern science tells you. What about ancient wisdom that tells you that air and water are elements? Earth is an element.
Sir. Yes,
So
sir. I have
which
many
authority
queries, sir. Actually, I have many queries comparing the ancient science and the modern science technology. There are various differences in the concepts.
So
and
which of
the
them do you accept, the
modification.
ancient authority or the modern authority?
Sir, looking into the present day world, many experimentation part can be done. But if we take
No,
into
I am asking you a very
consideration-
simple question.
Yes,
Given
sir.
two authorities which give you logically contradictory answers, which authority do you accept?
Present day, sir. Present day
Why?
one, because we are living in the present moment and we need to think about the present day.
So
Because-
you go by the latest fashion?
Exactly, not like that. Taking into consideration few aspects of the ancient history, we will just go for the justification using the present day technology, sir.
So the ancients were stupid people.
It's not like that, sir.
Notice who proposed the atomic theory first? Democritus, right?
Yes, sir.
And after Democritus, people believe that there is no such thing as atoms.
But later on,
So later Democritus was proved right. How do you know that that is true? Notice that John Dalton said atoms are indivisible.
yes, sir.
And that was proved wrong.
But later on, they found it was right, no, sir.
Yes, and why should you believe that what we believe now will not be proved wrong?
It all depends on the
Newton was
situation,
proved
sir.
wrong, right? Newton
Yes,
was
sir.
proved wrong by Einstein. And maybe Einstein would be proved wrong. What you believe today might be proved wrong in 20 years from now. And they might say, oh, the ancients were right.
Yes, sir. It might happen.
So you have to take the responsibility for your belief, not accept authority.
Okay, sir.
There is no choice, there is no option. You have to think on your own. And that's what academic intelligence means. Not accepting academic intelligence means doubting authority. I'm not saying that you should reject authority. I'm simply saying that you should not accept what the authority says blindly. Question authority.
Oh, okay, sir. Thank you.
Yeah. Other questions?
Hello, sir. Good evening.
Evening.
Sir, my name is Pragadesh. So what I understand from you saying so far is like we are kind of questioning the axioms. Am I correct?
Not axioms. Well, technically speaking, axioms are not true or false. So you can take the axiom that a straight line when extended will not meet itself, or you can take the axiom that every straight line when extended would meet itself. So axioms are the starting points for inquiry. I'm not saying axioms should be questioned. Of course, if the axioms result in logical contradiction, you must examine that. But claims, knowledge claims, what somebody says is true, knowledge claims must be questioned. So there's an important difference. Conclusions must be questioned.
So when we start thinking, then like either it's a trial and error, or like I understand axiom as like a convenient way to start to think about a difficult problem.
Yeah.
To like start in a simple way, and then that's how like, I'm a physics student. Not sorry, no longer a student, but
yeah.
The training we had in physics, like we will have a problem and we will keep it as simple as possible. Like we will, example, when we talk about like throwing a ball, we will remove the air resistance and all those things. We will assume it as a point particle So when we make such assumptions, like everything becomes like more confusing. But like, what is a point particle? The very definition of point is like we don't know. Like you were saying, a straight line is made up of so many points. What is a point in the first place? So when it goes like that, then what should we do?
Well, if you are going by Euclidean point, adding up, no matter how many points you put together, it doesn't become a straight line, because notice that a point is 0. No matter how many zeros you add, you just still get 0.
So
anyway, the question that you're asking is this. Let me give you an example of one way of thinking about knowledge claims. This is an example that I have used in many places. You must have learned that the definition of solid that you learned in primary school is solid is something that has a definite volume and definite shape. Liquid has a definite volume, but it doesn't have a shape. It takes the shape of the container, right? This is the definition that was given to you in your textbook in primary school or maybe secondary school. Do you remember that? Yeah. Okay. So let me repeat the statement. Solid has definite volume and definite shape, but liquid has only definite volume. It takes the shape of the container. Now, if you take a wheat grain, it has definite shape and definite volume. You can see the shape. So a grain of wheat is solid, but if you take a handful of wheat and put it in a container, it takes the shape of the container. If it is a kind of container like this, it'll take that shape. Or if it is a cylinder, it'll take the shape of the cylinder. Therefore, given that definition, you conclude that handful of wheat is liquid. If you take a sewing thread, put it in a container, it takes the shape of the container. Sewing thread, according to the definition, is liquid. And in contrast, if you take a soap bubble, it has a definite shape, spherical shape. Soap bubble is solid. These are the consequences following from the textbook definition.
Yes.
Do you accept those judgments that soap bubble is solid and handful of wheat is liquid and sewing thread is liquid? Do you accept the
No, one can start assuming things like that and defining things like that. Later, we understand the difference.
The question I'm asking you is, if you accept the textbook definition,
yes,
you have to accept the conclusion. But
yes,
you don't accept the conclusion. If you don't accept the conclusion, then you must reject the definition.
Investigate further and make proper definitions.
Yes, but you must the first thing that you have to do is to reject what the textbook says.
Yes, exactly.
So, and that is your responsibility. By critically evaluating the textbook, and you decide what to accept and what to reject. That is our responsibility as independent thinkers.
Yeah, I understand.
Right.
Thank you, sir.
That applies to everything else. So Newton said that there is something called gravitational force. And Einstein revised that to say that there is something called gravitational field. Do you need both force and field, gravitational field and gravitational force, or only one of them?
Technically,
okay,
Newton
that's not an easy question, right?
Einstein came up with the idea of curvature.
Yeah, and I'm talking about the field. If you have the notion gravitational field, do you need the notion gravitational force, is the question I'm asking.
If we interact with the field, then the force will arise. That's how it works.
How do you know that you need the notion force in gravity?
Technically, Einstein rejects the idea of force. Like for Einstein, gravity is not even a force.
Yeah, I'm not telling you what to accept. I'm saying you must be troubled.
Yeah, that is for sure. That is for sure, because so many people were living before us and each of them were saying so many things. So if we stop and like think about everything, it takes a lot of time and they throw us into a lot of trouble. And
you cannot learn anything without taking time.
Yes, obviously.
But you can develop your academic intelligence. You can strengthen your academic intelligence if you invest time on those mental activities. If you only gather information your intelligence doesn't increase. But if you engage with a question and start thinking like a mathematician, thinking like a physicist, your intelligence increases. It is up to you to decide what you want to do. Of course, it takes time.
Yeah, the problem is like we get lost in the puzzle of questions. Like once we start thinking like that, we get distracted and like so many different questions shows up.
Right.
Maybe
and you engage with them, you realize you can solve some of them, you can answer some of them, not everything. But you continue, as I said, learning is a lifetime job, so it never ends. And it becomes the discomfort that you experience when you invest time becomes a pleasurable activity. It's exactly like physical exercise. Physical exercise, physical activity becomes pleasurable. Mental activity also becomes pleasurable later if you get used to it.
Definitely.
Yeah.
Like earlier, Murugan sir was telling like the same thing. Like he was my professor at the university. After every class, he'll be asking like, "Do you have any discomfort?" Without discomfort, like then either I must be like an extremely genius fellow, or I did nothing regarding the class.
No, you can learn to experience that pleasurable discomfort.
Yeah. Thank you so much.
Sivakumar?
Sir.
No, Pradeep, yeah, you come after Sivakumar. Sivakumar, it's waiting.
Okay.
Sorry.
Okay. I will ask. So it's a very interesting and I think very important topic you presented. So going to school and college, throughout, we have to take what textbook is saying and write in the exam. So that is a way we have been taught. And later on, we realize that sticking to the textbook, in most of the cases, textbook guides you, or maybe they are mostly true, but not in all the cases. That's what you are trying to highlight. So we should be open to question and find new answers for new problems. So this thing we have been struggling, like personally myself, for last 10 years in social sciences. So my question is, like I am from Tamil Nadu, mostly I spend my time in Tamil Nadu. You have been to US, Singapore, and in India. Is there a cultural difference? Is it the academic intelligence and asking questions? Does it vary from one culture to other, or it's universal? It's the same problem everywhere, or what is the difference? So that we can self-evaluate where we stand and go from there. That's a question I wanted to ask.
The academic culture itself is a culture. So there is a cultural difference between, let us say, the sort of common sense culture or traditional culture and academic culture. Notice that in some cultures, doubting authority is sinful. Doubting is a sin. But in academic culture, doubting is a virtue. Okay, and there are different ways of behaving. All these are cultural. For example, the biology culture is different from the physics culture. There are some differences, but no contradictions. Maybe I should give you my own personal experience to answer that question. Otherwise, I may not be answering your questions clearly. Before I went to MIT, before 1978, I was in the traditional culture that you learn by sitting from asking a guru, and whatever the guru says, you accept. That was my responsibility. You don't doubt your gurus. And so I went to MIT to learn from these great masters, people like Noam Chomsky and Maurice Haller. And the first thing that I learned from there was that if I do not prove that my teacher is wrong, I'm not an interesting student. So in my first year, I went to Maurice Haller with the problem, and he listened to me very patiently. And then he asked me, okay, so what's your solution? And I said, I don't have a solution. I was hoping that you would be able to tell me. And Maurice said, I don't have solutions to everything. And I really don't know the solution. You go and find out a solution, come back and we'll have a discussion. And that was a culture shock for me, because here was this greatest phonologist alive at that time, 1978. And I went to MIT to learn from him. And he was telling me he doesn't know. And he expects me, a first-year graduate student, to find a solution, something that he cannot do. That was a huge culture shock. But since he ordered me to find a solution, I looked for a solution, I found it, and then talked to him. He was very happy. It became a research paper. And this culture of discovering knowledge on your own and the culture of proving that your teachers are wrong was something that I learned from the MIT culture. So there is a cultural difference. Students don't feel initially, they don't feel comfortable telling the teacher, you are wrong. But that's an important part of academic culture. And it takes some effort to get into that culture, but that's where the academic culture and academic intelligence begins.
Yeah, one more follow-up question. How do you manage that with Indian students? We know the culture is different. How do we bring out people from there?
My experience is that it is easy with secondary school students because they have not been fully indoctrinated. They have not been subjected to indoctrination. So it's easy to get secondary schools. We have just finished teaching a course for 8th grade, 9th grade students. And it was remarkable. The experience was remarkable. The kind of activities that they were able to do by the end of this program was astonishing. As they grow older, for example, first year undergraduate becomes harder. Masters, extremely hard. Okay. So let me give you an example, an anecdote. I did an activity, an experimental activity in linguistics with school students, 9th grade school students. And I did exactly the same activity with linguistics master's students and PhD students. And the school students, 9th grade students, were able to come up with the solution, were able to come up with the theory, while the master's students and PhD students completely failed. The point I'm making is that as you proceed with your learning in this particular mode of learning, of accepting everything that your teacher says, getting the information and reproducing it, your mind becomes less and less flexible. So to answer your question, if you can get them young, if you can get them, for example, when they're 5 years old and introduce them to academic intelligence, academic inquiry, by the time they complete their schooling, they would not need your help. They'll be on their own. It's much easier. But given that that is not the case, we have to decide where we are going to intervene. First year university, secondary school, primary school. And the answer is the earlier the better, but the system does not permit it. But it is, anyway, it is possible, at least for a few, to escape the tyranny of the school.
Okay. Thank you. Thanks, sir.
Thank you. Let us go to Aditya Verma.
No, Pranit actually was waiting.
Okay. Pranit.
Sir, good afternoon, sir. Good evening, sir. I'm Pranit. I have one small doubt, sir.
Yeah, your voice is breaking. Your net connection is not good, I think.
Yeah. Yes. Now, may I add?
I think you should put it on chat.
Hello?
Yeah, put it on chat. Your question, let me read your question. Good afternoon, sir. On the internet, we have a lot of educational content, but people are not aware of that content. Instead of useful content, people are influenced by unnecessary content by algorithm. How to solve this issue?
The issue is that the content that we have at our website, people are not aware of it. I don't know. I don't know how to solve that problem.
Yes, sir.
Yeah, all I can do is to offer learning opportunities. I cannot publicize. I don't know how to publicize the learning opportunities that you're offering.
Yes, sir. Actually, we have some social media algorithms, like YouTube Shorts, Instagram Reels, or TikTok. They have.
It's hardly able to understand. Pranit, can you put it your question in chat box?
Yeah.
Yes, sir. Sure.
Please put it in chat box. Let me go to Aditya Verma.
Good evening. My question is, you describe the artificial intelligence as that intelligence which can gather from all the existing text or whatever is available on the internet, and they give you an answer. So in that context, my question is whether artificial intelligence is capable of the kind of academic intelligence as described by you, whether or any sign of that is shown by the artificial intelligence systems as of now existing.
Yeah, there are two questions actually. One is, can artificial intelligence do better than humans? And I think right now the answer is, in many domains, it can do better than humans. For example, artificial intelligence was able to defeat a chess champion several years ago. And artificial intelligence, 6 years ago, there was a report that it could solve the traffic violation parking tickets. It could function as a kind of lawyer to escape traffic, paying a fine for traffic violation. There are many things that it can do. So there are domains where it can do definitely much better than humans. Alan Turing asked the question, can machines think? Now, there are certain kinds of thinking that the artificial intelligence has not yet been able to do. If the question is, will it be able to do in 10 years, in 20 years, etc., etc., the only answer I can think of would be, if you're thinking about a desktop computer, which doesn't have a body, there are things that humans do because of the body. And this is in neuroscience and psychology, it is called embodied mind. Humans have a mind in their body. And if you don't have a body, there are certain forms of intelligence that you cannot have. But the question would be, instead of a desktop computer, if you can create a robot which feels like a human, for example, a robot that if you pinch the robot's skin, it experiences pain. A robot that experiences fear, a robot that experiences anxiety. If you can create such a robot, in principle, one should be able to mimic human intelligence. The robot would be a human then. It'll be inseparable. That's my guess. I should confess I'm not an artificial intelligence specialist. So my answer is based on what I know from neuropsychology.
Okay, let us move on to the next question. The question from Krishnan. Does the pursuit of academic intelligence have an end?
No, there is no end. It's like the pursuit of academic intelligence is the same as higher order cognition. It's a never-ending mountain. You climb a mountain, the mountain doesn't have a top. You keep climbing. So the best you can get is, after climbing for 6 months, you look at the position where you were earlier. You say, oh, I was down below. I have climbed this much. And then you look up. How much do you have to climb? Endless. So it's like climbing an endless mountain. It never ends. And why not? You can learn until you die. That's a good thing to do. The learning does not stop with the getting a degree or getting a PhD. It continues.
So let me complete the second part of his question. That is, do we pursue academic intelligence to remind ourselves that knowledge, the way we use it, has inherent limitations, or do we use to pursue the academic intelligence to arrive at a description that are error-free?
Well, one of the things that we have learned from scientific inquiry is that human knowledge is not infallible, is not completely certain. So if we accept the idea that human knowledge is fallible and uncertain, then the best thing that we can do is to make efforts to minimize the possibility of error, not eliminate it, and reduce uncertainty. That also is a never climbing mountain. The moment you realize, or the moment you think that, yes, you have arrived at the truth, learning stops. So the answer to your question is, in the case of knowledge too, it is not just academic intelligence, but even human knowledge. It is a never ending mountain.
Okay, next question from Ananda Krishnan, Archana Krishnan. Academic intelligence comes with interest and curiosity. So does that also comes under the theory of multiple intelligence? But as per the theory of Gardner, academic intelligence is also divided into many different types of intelligence like mathematical, kinesthetic, and all.
Yeah. My take on that question is partly yes, but not exactly the way Gardner conceived it. Gardner thought of mathematical intelligence as one kind of intelligence, linguistic intelligence as another kind of intelligence. Mathematical intelligence is not just one kind. So take, for example, the intelligence that the other Ramanujam, not the Ramanujam sitting here, but the Ramanujam, A.K. Ramanujam, who died long ago, the famous Ramanujam. This Ramanujam is also famous. He had this outstanding capacity for coming up with conjectures. And probably the most famous mathematician for that ability. Now, the question is, did he have the ability to discover proofs and to articulate proofs? If you go by Hardy's, his mentor, G.H. Hardy's description, Ramanujam was not interested in proofs. And there is also a possibility that because he was not interested, he didn't have that kind of intelligence, the proof constructing intelligence. Notice the intelligence for discovering a proof and the intelligence for articulating a proof are slightly different things. So even within mathematics, there are different kinds of intelligences. And Ramanujam also came up with conjectures within existing theories. What about the kind of ability that, let us say, Euler, the famous mathematician who came up with graph theory, had? He could create mathematical theories. Ramanujam did not bother to create theories. He constructed or came up with conjectures within a theory. That's yet a different kind of intelligence. So there are multiple intelligences. What I'm saying, there are multiple intelligences within mathematics, multiple intelligences within physics, multiple intelligences within linguistics, every subject. And then you find that if you cut across these, some of these are shared. The intelligence for engaging with concepts is found in mathematics, in science, in philosophy, all of them. So the point I'm making is that Gardner's classification of intelligence in so many types is a good starting point, but we need to go beyond that.
Okay, so next question is Anand Joshi. Is an intelligence person dependent or a person independent? Is intelligence needed to be divided into academic, social, political, and so on?
I'm not quite sure.
Anand Joshi, can you come and explain your question?
Yeah.
Can you unmute?
Yeah, hello, sir. Can you hear me?
Yeah.
Yeah, sure.
Yeah. So basically, the discussion which is going on, I came to know that knowledge is not intelligence, right, sir?
No, not any academically intelligent person must have understanding, but that is not sufficient. There are also abilities, mindset, and so on that goes into intelligence. Yeah, knowledge is not sufficient.
Yeah, knowledge is not limited, right?
Yeah.
So we cannot say knowledge is intelligence. So right, sir?
Yeah.
So if I have an intelligence, whether it is dependent on, because knowledge is dependent on person based on its background, culture, what condition he has gone through from his childhood till his age. Depending on that, he thinks, right?
Yeah.
Yes.
It's
so
shaped
we can't
experience.
Yeah, his experiences, what culture he is brought up, just like you have said that Singapore and all those examples which you have quoted. So basically, I want to say that when I talk about intelligence, is intelligence different for different person, or is it just intelligence?
Oh, it varies. No two people may have exactly the same kind of intelligence. So there are many ways in which my wife and partner, Tara, she is far more capable than I am in many ways. And I would like to believe that there are areas in which I am better, though she would doubt it. So take, for example, the intelligence needed for puzzle solving, the crossword puzzles and other kinds of puzzles. She's extremely good at that. And I have no idea how to do that. There are many things that I cannot do. And she can do that effortlessly. And I think this is, by and large, this is true about all of us.
So, sorry to interrupt you, sir. So is that she's more intelligent than you? Is it like that?
More intelligent for certain kinds of things. See, there are different dimensions of intelligence. And if you compare any two people, you might find that along one dimension, X is more intelligent than Y. Along a different different dimension, Y is more intelligent. So it is very difficult to say person X is more intelligent. So the whole idea of gifted education program is that there exist gifted people and there exist stupid people. Instead of asking about gifted people and non-gifted people, we should be asking, what are the gifts that each of us has? And then you will find that every person has some gift or the other. And it's important to, nurture those gifts. So I have, I think, a certain kind of intelligence that makes connections across subjects. But it came out of 50 years of hard work. But when it comes to implementing experiments, I can design experiments. I don't know how to implement them. I'm pretty bad. I'm really, really bad in finance. In fact, I would say I'm pretty stupid in finance. So I find it difficult to think like, for example, a banker. I find it difficult to think like an entrepreneur. So, each of us has their own dimensions of intelligence. Some are good in some dimensions, others are good in some other dimensions. They're not comparable.
Okay, thank you, sir.
Hi, sir. I'm Pranit. Sir, for past for few decades for five years, our learning methodology is completely changed, sir. Like we don't need to go to any classroom, and we are studying in the virtual online classes. And also our learning habits, nano learning, or our learning methodology is completely changed. Even if we take any kind of learning, if you take some social media apps like TikTok, or if we take some Netflix or such things are there, right? We are our human entertainment or human dopamine level is completely changing. Who are using electronic devices, their memory activities changing, sir. Can we adapt, or can we use the social media algorithms which are using for entertainment purpose, can be used to educational purpose? Like we have a lot of content in the social media, in the internet MOOCs. MOOCs, we have a lot of, all universities are providing MOOCs content. Hello?
Yeah.
Am I audible, sir?
Yeah.
Many are providing MOOCs content, sir. All universities, their own MOOCs is providing different lessons and different or on YouTube, and their own website is also available. But due to the large content, each lecture is about 1 hour 60 minutes. But the catchy or key moments for in 1 hour, which the tutor or the instructor will be, there are some few key moments which can be connected to the audience or students. With that key moments only, the dopamine will release, right, sir? With that dopamine only, they can be sit for the next class also, or next doubt, or everything will be arrived in that few key moments. But if we are recording and if we are releasing that open source, it is very great, and it can be that MOOCs content or the educational content is only used by intellectual people or the people who are aware of education. Lot of
Pranit, can you put it your question in chat? Can you put your question in chat, because a lot of other question people are there.
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Okay.
If we go back to some few centuries, due to some wars or due to some calamities, whatever it may be, before the independence, or if you take if you conclude like before independence, a lot of our mothers and grandmothers didn't got chance to educate themselves, even though they are good at education. Their parents or whoever take care about them, they will only consider male or the one who is going to lead the family for future. They only thought those children, but the remaining
Pranit, can you start?
yeah.
Can you ask a question in one sentence?
Definitely, sir. Definitely. Sorry, it's a lot of emotions came out.
Can you put your question in the chat box so that we can deal with other questions? So some people are in the queue. So let us go with the questions.
Simple question,
one
sir.
by one.
Yes, sir. Can we use the content in the MOOCs to social media? Like we can cut it into short, chop it into short key moments, which can be useful to everybody. That's it.
It depends upon what you want them to learn. And there's an important distinction between entertaining people and educating people. Educating people can lead to pleasurable learning, but that is not entertainment. So I'm not sure about social media. MOOCs, yes. And if you don't want to take the trouble of investing time and effort to learn something, chances are that you will not learn much anyway, even if you're entertained. Learning requires considerable effort and time investment. Otherwise, there is no learning.
Okay. Vivek, can you wait for a few seconds? Let me go to the next question. It's Deva Shankar. So you start telling something. Do you have any question? Light as response. Deva Shankar?
No, sir. I just made a comment, sir.
Okay, right. Again, let me go to Mritanjaya. Hello, sir. I'm Mritanjaya. My question is there a lot of subject that we are taught, and I always try to think and figure out the reason behind the lessons, the formulas, etc. But our subject are vast. It's not possible to cope with self-reasoning and speed at which we are taught and told with exam, right exam. What should we do in this situation, sir?
Well, I don't know what to say about that, because there are two different goals. One is doing well in the exam. For doing well in the exam, you don't need anything other than the ability to cram things and practice things such that you can do things mechanically. But that is not what I have been talking about as academic intelligence. Doing well in examinations need not require academic intelligence. If you want to develop academic intelligence, you have to find some time, devote some time to do well in exams, and devote the rest of the time in developing your mind, such that your mind becomes stronger and more flexible and faster. There's a trade-off between how much time you invest for these two different activities. I don't know if that answers.
Shall I, sir? Shall I interrupt?
Please hold on. Let me go to the other question. Otherwise, you already talked. Mr. Vivek, can you go ahead and ask your question?
Yes, sir. Sir, my question is: there is some form of an intelligence which is not conditioned by any academic conditioning or any training. There is some sort of an intuitive way of telling something is right or wrong. For example, when I went to my native place in a village in South Tamil Nadu, there are these old old grandmothers who very instinctively say something is right or wrong. They're very, they don't have any academic training as such. They're not trained on anything like a psychologist is getting trained on what is right and wrong. They very instinctively say this person is selling something at higher cost, this person is lying, this person is not trustable. And that is also some form of an intelligence which is not being trained. So how do we sort of, that's more like an intuition form of a unconditioned way of sensing something. So how do you think that can be nurtured in somebody, sir, on somebody?
There are two answers. One is that academic intelligence does not include what you mean by intuition, imagination, insight, and so on.
Yeah.
It's in fact, it also a great deal of academic intelligence comes from the human limbic system and the seat of emotions and so on. So academic intelligence doesn't exclude any of those things like insights and so on. Insight, imagination. In fact, people like Einstein and people like the Hardy and people like Euler had extraordinary imagination, extraordinary insight. You need that for academic intelligence. But these are insights and intuitions that come from constant practice, constant exercise of the mind. The other is there are certain kinds of things which academic intelligence as yet have not been able to guide us. And this is what you mean by reading emotions. So I'm very painfully aware of that because I cannot read people's emotions. When I talk to a person, I don't see things like the person's face turning red or the voice changing, becoming tense because of some emotional problems and so on. I'm extremely, I would say I'm incompetent in reading emotions. I wish I had that ability. The question is, can the study of emotions and the realization of emotions on the face and so on, or the body language, can help us do that? To some extent, yes. But there are also certain kinds of natural tendencies that also come in the way, which no practice can improve. So the ability, for example, to detect discordant notes when somebody is singing. There may be people who are blind to those differences. Though some of those inherent properties, genetic properties, or the neural properties, which no amount of training can change. So the gist of the answer that I would like to give you is that there are certain aspects which training in academic intelligence can increase, certain other things, not really. So we do the best we can. That's all I can say.
Yeah, thank you. Thank you.
So next question from Archana Krishnan again. A person might have intelligence which he might not be aware of, and he might come to know about it in the middle of his life journey and switches his path. In that case, does it mean that the path he was following all these years does not open up his intelligence, or does it mean that he is not intelligent in that field? Many people are not lucky enough to switch their path. Does not mean that they are unlucky.
I would say your life, not everybody can be fortunate. So I began my college studies with physics, which I hated intensely. And everybody thought I was, stupid because I was getting poor grades. And I continued doing that. In all my exams, I did extremely badly until I got into a PhD program. And after my PhD, I started studying physics. I discovered I could do physics. I could do formal logic. I could do mathematics. I could do other things. But that was because I was extremely fortunate that I discovered that I can learn on my own. There are many people who may not be that fortunate. I don't know what to say about that. Fortune is not something that we can control. These are accidents of your life. I also had people who were mentors for me, and they helped me considerably. Not everybody may have good mentors. That's just bad luck. But as educators, all that we can do is to provide learning opportunities to as many people as possible and leave it at that.
The last question is.
So my question was, does he made good use of his intelligence, or has he not discovered the intelligence?
The first part of your question, I didn't hear.
Yeah, your voice was breaking. Can you repeat the question?
Does it mean that he has not discovered his intelligence, or is he not able to prove the pathway properly?
Difficult to tell. Until you have invested time in developing your intelligence, you don't know whether you have it or not. So when I was about 15 years old, I wanted to sing very badly, classical. I wanted to become, good at classical music. And I invested huge amounts of time practicing. But I couldn't sing the re of what you call Maya Malvagaula. I always went off key. After practicing for about 6 months or so, when my sister was singing and she was learning effortlessly, I decided to quit. But at the same time, I was practicing on my own. And I could sing fairly complicated things. And when I was about 30, 32 years old, or maybe slightly older, my wife, my daughter, and I went to a music teacher. And I assumed that since I was practicing, for several years, I should be able to do it. I discovered that I couldn't sing that particular note, the re of Maya Malvagaula. That's when I discovered that I have a neural problem, that I would never be a good singer, no matter how hard I tried. But these are rare cases. The point I'm making is that unless you put your effort in, you would not know. And the opposite case is my daughter, that we thought she was not good at singing because she was doing Indian classical stuff. And when she discovered Western singing, she suddenly flourished. And we were totally surprised that she was a fantastic singer. And that would not have happened if she had not bumped into voice training for Western music. So you have to try. You cannot quit before you try.
So let us ask Radhakrishnan. So you have raised your hand. What's your question?
Yeah, thanks for the opportunity. It's a very nice talk. You cover all the point in philosophy, other things. But my question is, you talk about academic intelligence. The intelligence means you are talking about from the birth of the child intelligence, or to learn to change it. Because when you say child growing, because when a child growing, the child doesn't know any objects. So mother can teach her, they slowly learn. Okay, that's one intelligence. Or other hand, we talk about the world. If the Jews is very brilliant, people are saying, yes, not me, the people saying. So that intelligence become for that DNA purpose, they have more intelligence. Or people does not learn anything, okay, because he does not study any education, but maybe intelligent in different ways. So how to distinguish these three things?
How to, sorry, say that again. How to
distinguish, because of the intelligence means from the birth, or from DNA, or from learning from the subjects.
There is of course a DNA factor, but we don't know what constitutes the DNA factor and what constitutes acquired abilities and so on because of experience. So granted that DNA is indeed a factor, the best thing to do will be to try and develop as much as you can along different dimensions. You don't know until you have tried it. So as an educator, what I would do is to assume that all my students have intelligences in all different dimensions. Some of them may have intelligence along one dimension and less in some other dimension. I don't know what these things are. So as an educator, all I can do is to provide opportunities to learn, to become more intelligent along all these directions. And the student should also do the same thing. Try and develop as much as you can. And don't worry about what is innate and what is not innate. It's exactly like your body. Your body can become stronger and faster and so on if you have the right kind of activities and nutrition. And you don't know whether you are Olympics material or not until you have tried it, until you have worked hard to be there. So why not give yourself a chance And why not give your students a chance? That's the most practical way of looking at it.
So let's go to Tejasvi. Can you ask?
Yes, sir. One more doubt I have. Like, I wanted to know, like, apart from academic intelligence, I wanted to know other contemporary ways, apart from mind gym activities and the academic intelligence, what are the other contemporary ways in which we can bring awareness in the students through experiment? Like, the education in the students nowadays is lacking, sir. So I, as a facilitator or an educator or teacher, wanted to increase the teaching methodology through experimentation part. So what are the contemporary ways through which I can inculcate in the students?
Let me see if I can do it using two examples. One is, you mentioned experimentation.
Yes.
Now,
sir.
actual implementation of experimentation requires considerable time. And not all things can be implemented by students. However, designing experiments is possible. You don't have to go to a lab. Experiment design, you give a hypothesis, give a conjecture, and ask students to come up with an experiment design to test it. They don't have to actually go and test it. So one of the things that I do is to provide training experiment design, not necessarily experiment implementation, because some of them will require instruments, some of them will require laboratories, some of them will require field work. So there are many things that students can learn by designing experiments or evaluating experiment design. So do those things which don't require that much time and level of detail. I don't know if that answers your question about experiments. The other, so take for example, they may not be able to implement experiments with respect to, let's say, that's something that requires, let's say, lab work in terms of fMRI, functional magnetic resonance, to investigate the structure of the brain. But they can surely understand what fMRI does, functional magnetic resonance does, and then design an experiment such that somebody else will be able to implement it. I think that should be sufficient for school education, and for undergraduate education, that should be more than sufficient. As for things that education does not work yet, take something like ethical intelligence, the ability to decide for yourself what to do in your life, doing what is wrong, understanding what is wrong, and understanding what is not wrong, what is ethically desirable, and living that way. Now, rational education through ethical rationality can pave way to that kind of intelligence, but there is also an ethical sensitivity, which is an emotional factor. I don't know if you can train students to become ethically more sensitive. You can make an attempt, but if there are sociopaths or psychopaths, they may not develop those abilities. So there are certain kinds of limits, but at least you can do what, academic ethics, constructing ethical theories and evaluating ethical theories and thinking carefully, which is currently not done in school education or university education.
Sir, sorry,
you can develop that aspect.
Sorry for interrupting. I have my kiddos who are in 7th grade, and they are very super talented and super intelligent, and they wanted everything in the experimental way. They don't want class. They always wanted discussions, debates on researchers, and they always wanted to go for the research work. So I wanted to know some of the ways so that I can implement in my class. Thank you, sir.
Yeah. I think my advice to you is go to our website, and it gives you various kinds of pedagogies for doing that. You'll find videos and, in fact, classroom discussions as well.
Yes, sir. Yes. Yeah. Thank you, sir. Thank you so much.
Okay, we have the last question. It's from Mitresh. So thank you for wonderful session, sir. Is intelligence dimension directly proportional to the person's interest? For example, I come across a person who who was average in his education, but practically excellent in his technology and in his implementation, that he did his graduation degree. When I had a quick chat, he said he's very much interested in his technology and hence he could do that. I also met topper in the class who is not shy as much as in practical job.
Yes, I agree.
All right, so we have completed all the questions. If it's the time for winding up the session, if any of you have any question, please raise your hand. We'll wind up the session. So.
Sir, one more doubt, if you don't mind.
Yeah.
Can I go ahead?
Yeah, go ahead and do that.
Sir, is rational thinking better in the present contemporary world or the ethical sensitive thinking?
Ethics is not averse to rationality. You can have ethical inquiry and rationality in ethics. Ethics has two components. One is rationality, like anything else, rationality, and the academic aspect. There is also sensitivity. So there is a ethical response. So, for example, consider this: when a mosquito lands on you, you kill it almost like an automatic gesture. You have no ethical compunctions about killing a mosquito. Okay, what about killing a cockroach? There are some people who can kill a cockroach without any ethical pang. What about killing a spider? Again, some people may have moral pangs, others may not. I've seen people who, when they see a hurt beetle, they experience some kind of pain. They have ethical discomfort. Now, where do you stop? I don't think any of us has any moral pangs about killing bacteria, taking antibiotics and killing bacteria, but there might be people who might worry even about that, even about plants. As you proceed, though, towards getting closer and closer to humans, some people may have moral pangs when you kill a frog or a snake. I once had to kill a snake, and it was extremely painful to kill a snake, but I have no moral pangs about killing cockroaches and spiders. So it's a question of ethical, emotional response to things that are ethical or not ethical. That has to be combined with your thinking about ethical aspects. Rationality comes in there. So it's a combination of your heart and your neocortex. Heart meaning the limbic system.
Sir, one more and the last one. I'll end it with this question. See, we have in the previous days, and the olden women tell that, like whatever I have heard from my grandma, that during the marriage, we will choose 18-year-old girl will be married to a 21-year-old man. Why the age gap? And I asked my grandma that why the need of that much age gap. So my grandma said that the maturity of the neuropsychology status or anything of the men will be very less when compared to women, it seems, at the age of 18. So how far is it true, sir?
I don't know. I tend to distrust these claims about things like men are from Mars and women are from Venus. It is true that there is a certain aspect of earlier maturity, puberty, and so on. The onset is sooner in women, but I'm not sure if there is that kind of difference between let's say 20-year-old male and 20-year-old female. To the extent that I can tell on the basis of the evidence, I don't know. I have not seen that kind of difference. And a great deal of that stuff could be simply mythology.
Okay, sir. Thank you, sir. Thank you so much. And sorry for asking these many questions.
That's fine. Let us close it. Jam, do you want to add anything? Or can we go ahead and wind up the session?
I just wanted to add one thing to what I mean, in the discussion, I see that many of the comments and questions almost were assuming that intelligence is measurable, comparable. Typically, is this, somebody has greater intelligence than somebody else, etc. I think this is also something to be thought about and questioned seriously. I mean, what is it? I mean, if we start talking about describing what it is, very often, it's very hard to come up with measures and agree on measures, right? And I mean, even whether it's comparable at all, and on what basis do we compare, etc., etc. And now, and Mohanan again and again kept talking about multiple dimensions as well. Now, when you have multidimensional quantities, comparison gets only harder. I think anyone who does science knows that. Not impossible, but I'm just saying that then we need to engage with the difficulty of what we are talking about. Whereas we tend to, brush a whole lot of things aside. And so I just wanted to add a word of caution here on that, because this seems to be kind of implicit in the discussion very often, and that needs questioning. Yeah, thanks.
Jam, did you want me to respond, or?
I would be very happy if you responded. But...
Oh, okay. So my response is absolutely. In fact, I think trying to measure, especially in the education context, measuring students' achievement is probably the worst thing that you can do to the students. I think we should, try to help them develop their intelligence without, measuring what they have achieved, so that all the shame and the anxiety about succeeding or not succeeding will not affect their future learning. And I agree that given so many dimensions, even within a dimension, it is not possible. Within what I think is a dimension, there may be many sub-dimensions that I'm not aware of. And our understanding of these dimensions is actually only beginning to come up. At that level, I think trying to measure what we do not understand what it is that we are trying to measure. It's a dangerous thing.
Yeah, absolutely. Yeah, and I wanted to emphasize this because it is dangerous. And that's exactly why.
Exactly, yeah.
And academic, especially when we're talking about in the academic context, a whole lot of academic reform, academic engagement really falters at this single linear order that we bring everything to. And therefore, I mean, if we are discussing academic intelligence, this is one of the things that we have to, upfront criticize and work against.
If I were the emperor of this world, I would ban all ranking of students and all so-called gifted education programs.
Well, I hope you'll be emperor somewhere where I can come along. So I'll join. Yeah. Thank you. Thanks.
All right. SK, Dr. SK, you want to add anything?
Fine. I think with it's okay.
Okay. All right. So it's a formal vote of thanks, and so actually it's my pleasure to thank Mo, who has readily accepted our invitation, and I had a sequence of interaction with him through email, so it shaped me how this program is going to be. It's very interesting. Lecture is also very interesting, and I see that many of the participants enjoyed this lecture, and we'll have a good feedback. I assume that we get a good feedback. I see that a lot of people are saying good about the lecture. My thank go to Mo. Thank you very much, sir. Thank you. We'll keep in touch with you. We want to have many such lectures in future. And my thanks go to Dr. Jam, who has introduced the speaker, and SK, who connect more with the with this PSL. And my thanks goes to all the audiences who has got very patient and listened the entire lecture and participate in it by way of asking questions. Of course, some of them may not get on the entire satisfaction due to the time limitation. We are winding up. I thank all the audience for this. Thank you very much. And I want to thank Sundar, who is behind the scene, operating the whole technical system. Now he's seeing that the things are connected together. Thank you, Sundar. And thanks all. Thank you very much. Thank you.
Okay. Bye-bye. Bye now.